Right. So as we've seen so far, oftentimes the standard way of interacting with the database, of being able to do all the CRUD operations, can be somewhat limiting. There's a few things that we might want to explicitly provide some kind of algorithm that encodes some heuristics, some rule, some business rule that cannot be encoded with the normal static interaction with the database. Right, so what store procedures allows it to do is just do that, right? Be able to encode programmatically an algorithm so that we can explicitly say what we want to do. And typically we'd like to be able to have access to all the common constructs that we would expect in a full-blown programming language. Right? We like to be able to do abstractions. We like to be able to do pass arguments. We like to be able to do modularization. We like to be doing looping. Right? We can iterate over data structures. We like to be able to do branching with if statements and if then else and whatnot. So all these kinds of things are available in store procedure, just as you would expect in a full-blown programming language. Now, where it's a little bit different is that the types of things that you manipulate, the type of data that you manipulate in other programming languages, typically is based on some classes or objects or some primitive data types, right? So that's a little bit different in a database, since the primitive data types here are rows, are tables, right? Are fields. That's the bread and butter of what you're manipulating in a database, right? Just like you can instantiate a new object or create a new array or pass around a reference to a variable in programming languages. Here, what you manipulate is rows, tables, fields, and whatnot, right? Plus variables and things like that, primitive data types as well. So a lot of the data manipulation that occurs in a store procedure is manipulating and interacting with queries and results from these rows and from these tables. Okay. So basically, what we'd like to be able to do is encapsulate repetitive tasks, things that we normally would have to do manually multiple times, and we find a pattern as good software engineers. We're looking for patterns, things that we repeatedly do manually, and we don't want to do manually. We're lazy. A good software developer is a lazy software developer, right? Once you've done it once or twice manually, it says, "Ooh, I can automate this," right? And I can encapsulate it in some algorithm, so I never do it manually ever again. So that's what I like to be able to do: encapsulate algorithms. Now, so there's a lot of good things about using store procedures. It's as close as you'll ever be to the actual data, right? Anything outside of the database is, by definition, going to be slower than whatever could execute right on the database, right? Anything else would have to go through some kind of API, through some data conversion, some mapping between the two worlds. But here you're as close as you'll ever be. So performance certainly will be much faster if you're running right on the database. Also, you can create several layers of abstraction where instead of giving direct access to folks to the actual tables, instead you provide an algorithmic API that hides the direct access to the tables through some very well-defined API. And then you can control the security on those store procedures as opposed to controlling them on the individual tables. Right? So it gives you some layer, in between that allows you to have much more full control over the data. Right? The cons, right, everything is a compromise. Right? There's always good things and bad things. The bad thing is that adding new algorithms that need to be executed on the same database, that adds new burdens on the database. The database is already busy, answering select statements and inserts and updates and deletes, doing its core thing. But now it has to steal some CPU time to also run your store procedures, right, that have to execute and whatnot. Also, it's yet another technology to learn, right? You have all these technologies in between. You have You have JavaScript and HTML in the front end. You have Java in the middle. You have JDBC you have in the middleware, and now you have SQL, and now you have stored procedures. So something else that you need to maintain, things that need to be tested, and now you own that. So it's yet another layer of abstraction, much more complication. Perhaps you might consider and say, well, no, I'm not going to do it in a stored procedure. Oftentimes, developers go back and forth. Should it be a stored procedure? Should it live in Java? Should it be one or the other? You know it's faster if you do it in a stored procedure, but you know it's one less headache if you do it in Java, right? And also you might not have the skill set, right, in your team to do a good job in a stored procedure. But you have the skill set in Java. So it's always pros and cons on what is it that your team might decide to do. Now there's three broad families or classifications of things that can execute in a database, right? We have triggers, we have functions, and we have the stored procedures, right? All three can operate or manipulate data, or can operate on some kind of data set, right? But they're used in three distinct types of use cases, right? One of them, the triggers, right, are meant to listen for particular events, right? For instance, might listen when things are being inserted or updated or deleted, right? And listen in for these things on a particular table, and then take some action, right? So that they could sit in between the event occurring and the actual table that is being updated, right? So you could take a look at, what is this person inserting? What is this person deleting? Should it be deleted, right? If you're updating, you might have ideas that if you insert here, well, I need to go up and update a couple things over there, right? That one insert might become two inserts, right? So triggers allow you to write code to handle events that occur in the database. The functions, like the name suggests, are something that executes, calculates some kind of value that can then be perhaps used as part of some other calculations, right? For instance, as part of a select, or part of a where clause, right? That you want to compare a particular field against something that can be calculated, right? That can be we need to iterate over a couple of things, count a couple of things, or add a couple of things, right? Average out a couple of things, and then the result, I can then use it as a predicate, part of something that can be calculated, right? And then you have procedures, things that can execute, and typically are executed at the command line, right? Where you're running a procedure that you can execute either in the command line, or they can also be invoked from outside, through some API, or through a Java API that you can execute that stored procedure and then perform some operations. Now, depending on which one you're using, they have some limitations, right? There's some things to consider. For instance, only the triggers and the procedures can modify data. Modify data meaning, as literally updates, right, or inserts, or deletes. Right? Those are updates. They all can do selects. They all can read data. They all can do a select and retrieve data from tables and whatnot. But only triggers and procedures can manipulate data. Right? Do an insert, like for instance, an incoming insert, I can convert it into two inserts, right? Or an incoming insert, I might decide to make a delete somewhere, okay? Or one delete becomes one insert, another delete, or some update, right? So triggers, procedures can manipulate the data. Functions are not meant to manipulate. They're meant to read some data, retrieve some data across multiple tables, calculate something, and then return a scalar or some list of values that can then be used for further computation, right? So yeah, functions are not meant to change any data. They only read data from the database. Triggers are meant to handle some kind of event, right? And then operate on some data, right? And cause a secondary effect on some event that occurred. They're not meant to calculate anything and return for someone else to use in a computation. They don't return any data. They only operate on the data, right? So as a side effect of some events. So there, they don't return any data. Functions are always, that's the whole point of functions, right? They calculate a value, right, in terms of some select statement, some query, some operator, some algorithm that calculates something and then returns a particular value or set of values to be used as a collection. Procedures depends. You can configure them to take only inputs, only outputs, or both in and out. That you can pass in variables and parameters. They can read data, and then they can also return some values, either as selects, as table, as views, right, or as actual variables that are passed in as passed by reference. Typically, they're called triggers, event-driven, right? If there's a select, if there's an insert, an update, delete. Or function as part of a call, as part of like an where clause, right? You might call a function to calculate something for you, or execute it from the command line or some API for the store procedures, right? So those are the three main types of things that can execute. So here's the most trivial store procedure, right? Where we use the syntax create procedure, and then we give it the name of the procedure. Followed by some declarations of variables, some declarations of any parameters, optional parameters that we might have, and then a begin and end, right? Begin where the procedure starts and where it ends, and between the begin and an end, we can have any number of lines, right? That we can program our algorithm, and in here you can have all sorts of selects and inserts and updates and deletes, and loops and if branches and an intermix of these operations. Depending what you are, a procedure can do everything, right? But if you're a trigger, typically you only do selects, right? You wouldn't do any inserts, any updates, any deletes. It would mostly select statements and ifs and for loops and whatnot in here. So again, depending what you are. So this would be a create procedure or create trigger or create function, right? And depending what you are, right, you would be restricted on what you can actually do here, okay? So here's the simplest select, and what it returns when you execute it. Here we haven't executed. What we're doing here is that we are postponing the execution of this select statement up until we execute the procedure. When we execute the procedure, then the select statement executes as if we would have typed it at the command line. All right. So instead of typing this select hello world so many times. We can embed it here and then just run it whenever we wish by running hello world from the command line. Now, notice that we have in this select statement, we have at the end, we have a delimiter saying that this is the end of the select statement. Yes? The creation of the procedure or trigger or function also needs to be terminated. Somehow we need to tell the database that we're done. The procedure is done. We finished. We completed. Right? We're no longer manipulating the procedure. Now we want to go back to regular SQL. Yes? Right? And we typically, the way we do that is by providing here a delimiter. Right? Typically we would say semicolon and we're done. Right? But the semicolon here is somewhat ambiguous. Right? We're already using it for the select statements and the inserts and the delete and all the statements. So we need to be able to distinguish between I'm done with the statements here and I'm done with the procedure, right? If we just use semicolon, the database would interpret this semicolon here as being the completion of the declaration of the procedure. Right, and it would balk, right? It would complain, saying, "Wait a minute, that can't be the end, right? Because you don't have an end, you don't have this, that, or the other. It can't be the end, right? So to be able to distinguish between these semicolons in the statements, right, and the semicolon that you would use to terminate the procedure, we need to declare other delimiters, right? We have to say, well, no, we're not going to use this as the delimiter. Right, for ending the store procedure, it's a delimiter that has meaning later, right, when it executes. Right, it doesn't yet have any meaning. It only has meaning when it executes. Yes, So because we want to use a semicolon over here, we have to declare another delimiter. We can declare the delimiter using the delimiter keyword. The delimiter keyword allows you to declare what the delimiter is, and you can choose whatever you want. Some common ones are // @ $, right? Those are very common delimiters. So that's typically what you would do at the beginning, right before you start declaring your procedure. You declare your procedure, and then you do a delimiter, bringing it back to what it used to be. A word on some syntax on how is it that you invoke these procedures. It's slightly different from one vendor to the next. In MySQL, you would say call, and then the name of the procedure, and any optional parameters. Whereas in SQL Server, you might say exec. Right? So it's a little bit different. The syntax is slightly different from vendor to vendor. You need to just learn whatever syntax your particular vendor you're using. We're going to be following the MySQL syntax here. Other couple of things here. When just like you can remove tables by using the drop keyword, same thing with procedures. You can drop a procedure, so you can redefine it perhaps, or you can use alter, just like you use alter on a table by to add a new column or rename a field and whatnot. Same thing you can do. Use alter for procedures that allows you to just redefine the procedure and say, well, this procedure already named a particular way. I want to provide the algorithm to be slightly different. If exists, allows you to prevent that you're going to drop it or alter it and whatnot. If it exists already, otherwise don't do anything. Here's the syntax for altering a procedure, where you would say, I want to change the procedure that was already implemented earlier, and want to redefine it with the following begin and algorithm. Local variables, you can inside between the begin and end, you can do for loops and branches and anything you would expect that you can do with any programming language. But also you can also declare variables that would be local to the procedure, that would not be accessible outside of the procedure. Although you can use variables that can session variables that can have access and behave as if they were global variables that can be viewed anywhere in the as long as you're logged in. Whatever values you have in that session, those variables are also available. But if you declare them inside of the procedure, they are considered to be local variables, right? And they're not accessible outside of that procedure. So here's an example of returning. This would be for functions and for store procedures, not for triggers. Triggers are not meant to return anything. But in functions and in store procedures, you can actually return a value. Your store procedure can evaluate, to an actual scalar value or evaluate to a result set from executing a select statement. So here we're executing a select statement over there, and right after that we are doing a return value where we are assigning to a variable here that we've declared. Here's an @ sign. This is a session variable. It's a variable that will live throughout the session as long as you're logged in and you're maintaining a session connection with the database. This variable will have will have a particular value. In this case, we're assigning it to having executed whatever the procedure we've just run. We run the procedure. When it evaluates, it returns 123. So now our variable has that value. We can select it, and it outputs the value of that variable. Here, just another example of calculating intermediate select statements, right? And when you run it, it displays multiple result sets as it calculates your select statements. Obviously, if this were much more sophisticated select statements, it would print out all the columns, right, and all the values and records that would meet that select statement. But only the last return has any meaning for being able to assign it to a particular session variable that we can then use as a globally. Here's just a slightly more interesting select statement that we're calculating here. The students that graduated in the 21st century, and it spits out a table. Again, this might have been inside of a for loop, right? Or the results of this could have been fed into a for loop and then iterate over all the students in the 21st century, right? And find out where join that with something else instead of a for loop. And as you're iterating over all these students, maybe you're inserting into another table, right? So you can iterate and you have all complex algorithm. As you're declaring procedures and functions, they can both take arguments, right? You can pass an argument as opposed to a trigger. A trigger doesn't take any arguments because there's no way for you to invoke it. You cannot invoke a trigger. It only gets invoked automatically whenever an event occurs, like an insert or update or delete on a particular table. Once they execute, they have access to perhaps the context in which they're running. For instance, they might know which table they're listening to, right? They might know what records are being inserted or what records are being updated, right? But they don't have any parameters that you can pass because you can't call them, right? They're invoked by some event. But procedures and functions, they can take arguments, right? For instance, they can take arguments from the command line, right? They take arguments for when it gets called from the where clause. You can pass in the value of some field, right? And then that field can then be used inside of the function to then do some calculation. Yes. So parameters can be declared when you declare the procedure or the function. Create function, the name of the function, and then variables can be declared. Name of the variable type, comma, variable type, comma, and so on and so forth. Optionally, you can also use keywords such as in, out, and inout, right? So that the parameters can be declared to be either passed by value or passed by reference, right? Whereas in some languages, it's always implied whether it's passed by reference or passed by value. Here, you can explicitly say whether it's passed by value or passed by reference, right? If it's in, right, that means that it's being passed in, right, from the outside, and anything that happens to that variable inside of the stored procedure will have no bearing in the original value that was passed in. So it's treated as if it were a pass by value, right? So you pass whatever value is inside, whatever you do to that variable will stay within the boundaries of the stored procedures. It will not affect the outside world. Whereas if it's out, it's meant to be used a return type, like a return value, which is pretty cool. You can have multiple outs, right? Unlike a function in Java or JavaScript, you can only return one single object, right? One single value. Here, you can return multiple, right? As part of the parameters declared as out, right? That can be calculated inside of the stored procedure or function, and then read outside of the procedure. Or you can declare it as in-out, both in and out, meaning you're passing it. Whatever you do to that variable will be accessible outside of the stored procedure, right? So this is kind of like a pass by reference, right? I'm passing you a reference to a variable. You can do whatever you want with it, and then outside of the stored procedure, I will see those changes. So you can be very granular on how you want your parameters to be treated by the stored procedure. Just a quick a couple examples on how this might work. Here we are calling a stored procedure, passing it the value 10, which gets bound to the variable var1, which is an in, right? It's in. So this variable that we're passing, note it's a literal, but if this were a variable, that variable would not change because it's an in, right? So it's passed by value. It only changes inside of the stored procedure. It would not have bearings on any variables that I would pass into the store procedure. Here we are passing a variable var1, and it's being set inside of the store procedure, meaning that outside of the store procedure, I will see that change. I will see that variable changed to this is a test, right? Because it has the keyword out, right? So it can be read from outside of the store procedure. Here's one that behaves both ways. I can pass it in, and it can be modified by the store procedure, and then I will see those modifications outside of the store procedure. So here's a couple examples on how this might work. Here we are declaring the increment parameter as an in-out, meaning it's being passed as a reference, right? Meaning that if I pass it in, that variable that I'm passing in equal to 10, when I pass it in, since it's in out, and inside in out, I am modifying and incrementing it by 1. Later on, outside of the store procedure, I can see the side effect of my increment variable that it has gone to 11, right? That the change actually occurred. So here's just a couple other examples of declaring other variables. Declaring a as an integer, str as a varchar, today as a timestamp, or declaring multiple variables of the same data type, tiny int, and then you can use internally to either set or select to assign these values. These are just variables being used here for just showing that you can declare these variables and then use them, right, as part of inserts or select statements, interspersed throughout your store procedure. So here you're inserting and then you're selecting, and you can have multiple of these even inside of loops, multiple inserts and select statements. Here's just another example of a local variable. Here we're passing in, let's see. All right, now we're declaring here this global variable var2. Notice it's a session variable, so it's visible everywhere. Okay, even inside of a store procedure. Here we're declaring a local variable inside of the store procedure, which is it's local, meaning it's not visible outside, and it only has a lifespan as the store procedure executes. Here we're initializing it to 1, we're incrementing it to 2, and then also the global variable we're incrementing it to 2, and then we display both of them, and they're both 2. Makes sense because the global one was 1 and it's being incremented internally, as well as the local variable. So they're both 2. They both changed. Right? But only the global variable has had side effects. Right? If we call this again over and over and over, the variable, add variable 2 will change from 2 to 3 to 4 to 5, as opposed to the internal variable will not change. Right? It won't change because it only lives for the lifespan of the store procedure. If statements, as you would expect, allows us to do branching and make build some logical paths that the application will take depending on their predicates. Here's variable 1, parameter 1, right? One of them is being passed in, another one is being calculated on the fly, and depending on the logic, we do either a select or some other select. Or we might do an insert, or we might do an update, right? So interspersed with logic. Here's just another version. Instead of using if statements, we use a case when. We used case when earlier, right, as part of a select statement. Here we're using it in a store procedure, where we, depending on the value of variable 1 compared against multiple scalar values. 0 and 1, we insert into one table, or we insert another table, or else we insert in a different table or a different value. Right, so again, you can do fairly complex logic. Here's the version of the case where each when has its own predicate. It's a little more powerful than this. This is more like the original if statement, right, where each if statement has its own predicate. You can also do loops. The 3 loops that you might expect, the while do, right? The while a particular predicate is true, you're going to keep iterating, doing inserts or updates or deletes, right, based on some logic, some if statement in here, based on whether you're going to insert into one table or another table, based on some business logic that you might want to implement here. So here's the while do, and then you have an end while, and inside here we'll do iterate as long as that predicate is true. You have instead repeat. This is kind of like the do while, where the predicate is at the end of the loop, right? So you at least execute this loop at least once, and then you decide whether you're going to repeat the loop again, right? And then you have a loop where you can label these loops and then be able to jump around, just much like in Java you might have break, right? And then you can label different places where you want to break, right? And continue looping at a particular location, a particular label in your application. Triggers are slightly different. Just like you would have a create procedure, you instead use the syntax of create trigger, right? And then the name of the trigger, and then you configure, when do you want this trigger to execute? You want to execute, listening to a particular table. But there's a whole bunch of types of events that I can listen to, right? I can listen to when inserts are happening, where updates are happening. When should I trigger? Should I trigger before the insert occurs, or should I trigger after the insert occurs? So you can specify when these things happen. Like for instance, if you do it before an insert, the record doesn't exist yet. Right? It hasn't been added to the database yet. So if you have a primary key in there, right, like an auto increment, I don't know what the ID is yet, right? So maybe if you need to know what the ID is, you probably want to trigger after it has been inserted, right? So it depends. Depends what you need. A before would allow you to do things such as perhaps abort the insert. And says, well, no, I don't want that insert, or maybe manipulate the insert. Maybe you found something wrong with the insert, right? That you want to validate and check and perhaps, or maybe make a note of it, right? That somebody made this insert and I want to audit it. I can keep an audit log of what's happening to a particular table, right? So the trigger allows you to say whether you want to do it before or after. And then whether it's an update, a delete, an insert, what type of event occurs on a particular table. So you could say, the trigger name before you insert in a particular table. Right? And then you can listen for triggers that are that I want access for every single row that is being affected, because it could be that a single operation might trigger multiple things to occur, right? And I like to be able to notify for every single row that has been affected. You could do a delete, and that delete might affect deleting 4 rows, yes? Or insert, and that insert statement could have a select statement, right? And you're inserting 10 rows. So the trigger, you can say that I want a trigger for every single row. I want to look at every single row. Or you can say at the level of the table. It says whenever there's an insert in the table, I want to be called. Or I want to be called for every single row that has been inserted. You can put it the level of granularity that you want. Here is for each row. I want to be notified for each row. And then in the begin end, you can manipulate the actual updates or inserts into that table. A word on naming your triggers. So it's a good practice to name your triggers is based on what event are you listening on, what table is being operated, right, and what action do you care about, right? So based on those two things, before and after, or whether you're inserting, updating, and deleting, you might call your trigger something like before an employee is updated, right? That's a good naming convention, right? So this would be before or after, the table that is being operated on, and whether you're doing an insert, update, or delete. Make sense? All right, so that's a naming convention we would expect you to follow also for the assignment that you're working on. So let's consider that we have an employee table, and we want to keep track of a history of what's happening to our employee table. Okay, so perhaps we want to log. We want to make a log, an audit log, that these are the things that have been updated. These are the things that have been inserted. Things that have been deleted, and so this is the audit log. And the audit log, we want to log the employee number that was affected, whether the employee was inserted, deleted, or updated, last name, when it was modified, and what action was taken on that particular employee. So here's a trigger called before employee update. Update. It says, well, before the update on the employees table, I want to be notified for every single row that gets updated in the employee before it happens. Before it happens, right? And what we're going to do in the begin, we would like to be able to insert into the employees audit table. We'd like to insert a record, right? And with these following values, the action field, we're going to say update. Right? The employee number, presumably the employee number, right? Since we are updating a record, presumably we already have that record. The record already exists. It's an existing employee, right? That record, the one that is being updated, should have the employee number, right? In the record that we're updating. Well, we have access to the record that is being updated, right? What the previous record looked like before it was modified. Yes? Before it was updated. And the way we have access to that is through the old keyword. Right? The old keyword gives us a reference to the original record, right, before it was updated. So we have the old employee number, which is, we're not going to change it. We don't want to change it. We're just reading it from it so that we have an employee number that we can feed it into our audit table. Okay? Same thing, we're going to copy the last name as well, right? And for when was it changed, we're going to use the now function that's going to return the current timestamp, right, of when this occurred. Make sense? Right? So an update to a table, right, triggered an insert into another table. Make sense? Right? Somewhat similar to what you're going to be doing for your assignment, right? When you are inserting into the roles table, right? You'll also need to insert into the privileges table, right? And be able to provide different privileges for different roles, right? If you're in the admin role, you get the read, write, update, delete, right? But if you are a reviewer, you only get read access. I forget. There's a table that explains all that, right? So that's if you're doing an update. If you're doing an insert, you want to know what the new record that you're inserting, right? It says, well, this is the new record that is about to be inserted in the database, right? Well, it could be before or after it's inserted. Nevertheless, that record that is going to be inserted is passed to you by reference, so that you can access the new record that is about to be inserted, or the record that was just inserted, right? So new is a keyword that gives you access to that. It gives you access to the new record that is about to be inserted. Okay? All right. All right.